In less than a single day, Earth erased its most powerful rulers. Not slowly, not gently, violently. 66 million years ago, our planet was not struggling. It was thriving at a level almost impossible to imagine today. There were no cities, no highways, no satellites orbiting above, no humans looking up at the sky, only raw nature. The late Cretaceous world was warm, humid, and alive. Sea levels were higher than today. Vast inland seas split continents apart. Forests stretched for thousands of miles, thick with conifers, ferns, and early flowering plants that had only recently begun spreading across the planet. The air buzzed with insects. The ground trembled under massive footsteps. The oceans churned with predators. Dinosaurs had ruled for over 160 million years. Humans, by comparison, have existed for only about 300,000 years. Dinosaurs dominated Earth for more than 500 times longer than our entire species has been around. They were not primitive monsters. They were highly evolved, incredibly successful animals. On the plains of North America, herds of Triceratops moved together, their massive frills and 3 horns forming a living shield against attack. Each adult could weigh up to 12 tons. If threatened, they lowered their heads like armored tanks, ready to defend the group. Nearby roamed duck-billed giants like Edmontosaurus, traveling in enormous herds and stripping vegetation as they moved. Above them, the sky was alive with giant pterosaurs, some with wingspans reaching over 30 feet. When standing on the ground, a few were as tall as giraffes. They weren't dinosaurs, but they shared the same world, ruling the air with precision and power. Beneath the waves, the oceans were even more dangerous. Mosasaurs, some stretching over 50 feet long, hunted like aquatic tyrants. Their flexible jaws allowed them to swallow prey whole. Giant sea turtles swam alongside them. Schools of fish shimmered beneath the sunlight. Ammonites drifted through the water like spiraled relics of an ancient design. Oh, and on land, one predator towered above all others: Tyrannosaurus rex, up to 40 feet long, nearly 9 tons. A bite force stronger than any land animal in history, capable of crushing bone like dry wood. Its forward-facing eyes gave it depth perception. Its sense of smell was extraordinary. It was not just large, it was optimized. For millions of years, this ecosystem functioned like a perfectly tuned machine. Herbivores shaped the landscape. Predators kept populations balanced. Plants absorbed carbon dioxide and fueled the base of the food chain. Even volcanic activity and shifting continents played their part in maintaining stability. It felt eternal. But space does not care about balance. Far beyond Earth's atmosphere, in the asteroid belt between Mars and Jupiter, countless rocky fragments orbit the Sun. Leftovers from the formation of the solar system 4.5 billion years ago. One of those fragments, roughly 10 to 15 kilometers wide, had been drifting quietly for millions of years. Then gravity intervened. A subtle gravitational shift, possibly influenced by Jupiter, altered its path and set it on a collision course with Earth. The asteroid accelerated as it fell inward, pulled by our planet's gravity. By the time it approached Earth, it was traveling more than 40,000 miles per hour, faster than a rifle bullet. Down below, life continued as usual. A Tyrannosaurus hunted near a riverbank. Hatchlings cracked open eggs in sandy nests. Herds migrated across plains. Storms rolled across ancient seas. There was no warning system, no telescope, no technology scanning the sky. The asteroid entered the atmosphere. The air in front of it compressed instantly, heating to thousands of degrees. The surface of the rock ignited. It became a blazing fireball brighter than the sun. Anyone looking up would have seen the sky split open. For a fraction of a second, shadows disappeared under the blinding light. Then it struck. The asteroid slammed into what is now the Yucatan Peninsula. The impact site is known today as the Chicxulub crater. The collision released energy equivalent to over 100 million megatons of TNT. For comparison, the most powerful nuclear bomb ever detonated by humans was about 50 megatons. This impact was millions of times stronger. The asteroid did not simply hit the ground. It vaporized it. Rock turned to plasma in an instant. A crater nearly 200 kilometers wide formed rapidly, tearing deep into Earth's crust. Shock waves traveled across the planet, triggering earthquakes far stronger than any in recorded human history. Forests within hundreds of miles were flattened instantly. Trillions of tons of debris were blasted into the sky. Some escaped into space. Much of it arced high above the atmosphere and then fell back down. As it re-entered, it superheated the atmosphere globally. The sky became an oven. Across continents, temperatures spiked high enough to ignite vegetation. Wildfires erupted almost simultaneously around the world. Entire ecosystems burned. Because the asteroid struck shallow seas rich in sulfur and carbonate rock, enormous quantities of vaporized material were blasted into the atmosphere. A mega tsunami, possibly over a mile high near the impact zone, spread outward across the Gulf of Mexico and beyond. Coastlines thousands of miles away were devastated. Within hours, the planet looked unrecognizable, but the most deadly phase was still ahead. Dust, ash, and sulfur aerosols climbed high into the stratosphere, where they remained suspended. These particles blocked sunlight from reaching the surface. Days turned dim. Weeks turned darker. Temperatures dropped dramatically in what scientists call an impact winter. Photosynthesis stopped. Without sunlight, plants began dying on a massive scale. As vegetation disappeared, herbivores starved. As herbivores vanished, predators followed. Even Tyrannosaurus rex could not survive in a world where prey no longer existed. In the oceans, the collapse began at the microscopic level. Phytoplankton died without sunlight. Zooplankton followed. Fish populations crashed. Marine reptiles like mosasaurs starved in empty seas. The extinction unfolded over months, perhaps a few years. By the time sunlight fully returned, roughly 75% of all species on Earth were gone. Every non-avian dinosaur had disappeared, but life did not vanish completely. Small mammals survived, many no larger than modern rats. They sheltered in burrows, feeding on seeds, roots, and insects. Their small size required less food. Their warm-blooded bodies helped them endure the cold. Some birds survived, descendants of small feathered dinosaurs. They were adaptable, capable of flight, able to escape harsh conditions. Crocodilians endured. Turtles survived. Many insects and amphibians clung to life. Years passed. The dust slowly settled. Sunlight filtered back through thinning skies. Rain washed toxins from the air. Ferns were among the first plants to regrow, a phenomenon scientists call the fern spike, visible in fossil layers around the world. Green returned to a burned planet. With the giants gone, ecosystems were empty, and empty ecosystems create opportunity. Mammals began diversifying rapidly. They evolved into climbers, runners, swimmers. Some grew larger, others specialized. Within millions of years, primates emerged. Much later, hominins stood upright. Eventually, humans appeared. We exist because that asteroid struck. If it had missed, dinosaurs might still dominate Earth. Mammals might have remained small, hiding in shadows. There would be no cities, no history, no voices telling this story. The fossil record preserves a thin layer of iridium, an element rare in Earth's crust but common in asteroids, marking the boundary between two worlds. It is a global scar, a reminder that dominance is temporary. Even today, asteroids cross our orbit. Most pose no threat, but impacts are part of Earth's history. 66 million years ago, power meant nothing against physics. Strength meant nothing against cosmic chance. Survival belonged to the adaptable. The asteroid did not just destroy a world, it reset it. And from that reset came forests, mammals, intelligence, and eventually us. The planet can change in a single day. Earth will endure. The question is not whether the world survives. The question is, when the next reset comes, who adapts?